Usually the engine used to power a gaseous standby generator system is a 4-stroke spark ignition or SI engine, and these engines are referred to as having a closed-loop ignition system. Your authorized service provider understands the operation of a closed-loop ignition system, the components within the system, and the key maintenance points to ensure reliable operation of gaseous generator systems. Most generator system SI engines operate on the 4-stroke Otto cycle principle. A mixture of fuel and air is drawn into and mixed in the cylinder on the first downstroke. The second upward stroke compresses the fuel-air mixture. When this compressed mixture reaches the top of the cylinder, a spark ignites the fuel mixture. After ignition, the burn from combustion pushes the piston down on the third stroke. This is referred to as the power stroke. The fourth stroke is an upward stroke to inject the burnt gases out of the cylinder through the exhaust. To ensure optimum power, precise engine sequence and exhaust emissions within the required EPA tier level, the operation of the engine adopts a closed-loop system. The term loop refers to the path the ignition system takes through the 4-stroke cycle. The engine is placed in a closed loop or path. Closed loop refers to inputs and outputs placed along the path to maintain engine performance within design limits through various loads and ambient conditions. In the closed loop, an electronic control unit, or ECU, utilizes sensors throughout the complete 4-stroke cycle from air and fuel input through to combustion and exhaust. Sensors on the engine input to the ECU exhaust heat, oxygen content, pre-ignition, and speed. The ECU calculates sensor input and gives command outputs to the Direct Electronic Pressure Regulator, or DEPR, to increase or decrease fuel pressure. We now have a closed-loop input feed to the engine. Sensors along the closed-loop path constantly feed input to the ECU while the engine is running. Crank and cam position sensors are fitted to measure engine speed. The signal sent to the ECU synchronizes the ignition system to the engine speed. For example, if the load pulls down engine speed, the throttle will increase fuel. A sensor measures the temperature of the inlet manifold air and works with the coolant sensor to maintain a constant, even air-fuel mixture when the air density changes. This sensor senses the inlet manifold pressure for the ECU to determine how much fuel is required for ignition in any given cylinder. The ECU sends signals to the engine throttle body to change the fuel mixture to the engine. The engine throttle position sensor tracks the shaft movement and position, closed throttle, wide open throttle, or any position in between, and transmits an electrical signal to the ECU to make any required adjustments. The inlet manifold pressure senses fuel pressure and inputs to the ECU to adjust the fuel requirements and control the ignition sequence to each cylinder. The direct pressure engine regulator receives input from the ECU to control the correct flow of gaseous fuel. The engine control unit, ECU, receives input from the various sensors in the closed loop and uses these inputs to calculate the outputs to the various devices that control engine operations, such as the throttle and pressure regulator. The coolant temperature sensor works together with the inlet temperature sensor to maintain a constant, even air fuel mixture when the air density changes. A catalytic converter maintains exhaust within the required EPA emission tier. Sensors upstream and downstream of the catalytic converter measure the correct fuel flow to the engine by sensing the oxygen content of the exhaust gas. If the upstream sensor reads the exhaust as too rich, the input to the ECU will trigger a decrease in fuel for a leaner mixture. The downstream sensor on a catalytic converter enables the ECU to sense the performance of the catalyst. The NOx sensor senses any change of internal engine pressure due to pre-ignition. When detected, the ECU will retard timing. The NOx sensor permits the engine to run on the most advanced timing before knock occurs. Your authorized service provider understands the operation of a closed-loop ignition system, the components within the system, and the key maintenance points to ensure reliable operation of the gaseous generator system. Consult with us regarding maintenance of your gaseous generator system.